Guys, welcome once again to another video. My name is Daniel, and if this is your first time watching my video, please I want to ask that you subscribe, you hit the subscribe button, you like this video and you share, because in this channel I talk about mathematics and computing. Okay, so in today's video I want to talk about the RAM, the microprocessor, and the storage. Okay, so let's start from the first one, the RAM. What about this RAM? So many people had different knowledge different idea about RAM, but I'm going to give you few things you need to know about RAM so that you should know how this RAM works. What is RAM? RAM is a temporary memory. The RAM is a memory, but a memory that has the capacity to store things temporarily. The RAM is not meant to store large data, and that is the reason why you see in your phone. Have you ever noticed in your phone you always see phone of like 4 gig and you will see 120 gigabytes? Now 4 gig RAM, why this one is what 120 ROM? Have you ever noticed that? Now on your system, also on computer, you will see on your laptop is having 4 gigabytes as the RAM and 500 HD as the hard disk. Have you ever noticed that? Now do you come to ask yourself, why is this always like this? It is like this because the RAM is not built, is not designed for it to store large data. Is not designed. The RAM only store data when they are meant to be used, when they are to be used. That's when RAM store data. And once the data has been used, the next thing that happens is that the data is off from the RAM. So it's a temporary storage device, okay, because it's a hardware, not a software. So that is for that. Now another thing about this RAM is that the RAM is what helps the RAM communicate directly with what I call the microprocessor. This RAM communicate directly with the microprocessor. Okay, what do I mean by that? So let's say, for an example, you want to run a particular program on your phone or your system. You get it now? So the RAM makes the program or the data you want to execute enter into, let's say this is okay, and I'll draw 3 at the third one. Now this is the case here. This is your micro processor. Get it now? This is your CPU and this is your storage. Okay, now how this works, sorry, this is your RAM. Now as this work is this, the program, the first thing is that the RAM, then the program is picked from this place, this guy here, okay, and moved to the RAM, and the RAM is not the one. It is in this RAM this guy will pick the program and execute it. Now any program, once a microprocessor want to execute a particular program, the RAM that program must get to the RAM first before. So the RAM there is helping, it helps the microprocessor, giving the microprocessor tasks to execute. So it's like an intermediary. So by the time you check the RAM, you did not see that particular program or the particular task, and that is when you will now move to your you move to your storage. Your storage there means your storage. This storage, it is meant to help the RAM. Since the RAM does not have the capacity to store things, to store larger data, to store larger file, that's the reason you see your storage, which is your hard disk, which is your SSD. They will always have, they come in large sizes, such like 500 HD. You get it now? You see such like 512 HD. No, so 512 gig, like that. You getting 1 terabyte, like that. So all those files, all your Microsoft Word, all your Photoshop, or your CorelDRAW, or your video editing software, those software are very heavy. They are found on inside the storage, inside your hard disk, inside your SSD. That's where they are located. But anytime you want to run a particular program, those programs, if the particular one you want to execute, move out from this place and enters the RAM. Once it enters the RAM, that is when this microprocessor can pick it from this RAM and do what, and execute it. Okay, so that is how it works. That's to tell you that your RAM, this is the reason why you see RAM is not always large. So the RAM has the capacity of storing large small files, small size of data. So I believe that has been explained. Now for the storage, for the other one, this storage here, I've also explained that. Now I want to chip in something. There is another one, something called cache. We call that cache memory. Now this cache memory, this is also a type of memory. You get it now? It's another type of memory. This memory is a memory that store things temporarily, that store frequently use data. Any data or any file you've executed over and over, this memory is the one that has the capacity of storing that. Let me give you an example. Do you notice that on your browser, most times when you check a particular website over and over, you notice that on that particular browser, when you just come and type the first word, first letter of that website, it gives you the full reason, because that thing, you have checked that website, you visited that website with that phone over and over, and your cache is a memory. That's your browser. And the cache has been able to pick that, oh, this person has visited this site over and over, and that is the reason why it noticed that a particular data has been executed. That's the reason why the cache will save it. And don't forget that the cache is also a temporary memory. Okay, so now if you notice this cache, you ask yourself, I know the question you'll be asking yourself, where then is this cache located? This is it here. Let's see for an example. This cache, now we come here, cache. Before, in between the RAM and the microprocessor, cache comes in. Now, the reason why cache has to come in is because cache help the microprocessor to get data that will be executed. Now, anytime the microprocessor want to execute a particular program, and he notice that he want to pick it from the RAM, the microprocessor will not go directly to the RAM. No, it will first and foremost check the cache. If the particular data that you want to execute is in the cache, then you know that the cache is closer to the microprocessor. Immediately it will pick it up, and this is the reason why microprocessor run faster. You get it now? But once it checked the microprocessor and the cache and it could not find that particular program or data there, what happens is that we call that cache miss. Okay, we call that cache miss. Cache miss is when the microprocessor has found a data or a file to be executed and inside the cache and could not locate it, it did not see it. So on that ground, that's when the microprocessor can move down to the memory. And if it is not here, this one here, we have to move the data down to this place. And this is how these things works. So these things work this way, but you don't know that these are the things that happen in your computer. I hope this is very clear to somebody. If you find this this video very helpful, don't forget to drop your question if you have one in the comment section below. And if you also find it very helpful, you could also just drop a kind of positive stuff down in the comment section. And don't forget to like this video. Don't forget to subscribe if you are yet to do that. I don't know what is keeping you. Thank you, and see you on the next one. Bye.